Alright guys, so today we're going to be doing this completely virtual, so if you have any questions, please get in contact with me, let me know. Unfortunately, we have to do this virtually because of the inclement weather, but at least we are able to meet and, meet, quote unquote, and go over the review sheet. So what we're going to be doing here, and what I'm going to be doing here, is going through the review sheet. I'll be going through an example of each type, or as many as possible. Well, not as many as possible, because I have an unlimited time, so I'm going to go through all of these here. So if there's specific ones that you're looking at, those there, go to those, or you can skip forward that to those parts. If there's parts that you understand, you can skip ahead. But they're all here if you need them. So here we go. We're going to go on and get started with this here. Now, problems 1 through 6. Find the value of x and state if it's a Pythagorean triple. Now, we know that it's Pythagorean triple if and only if they are all three integers, really positive whole numbers. There are no decimals, there are no radicals. Because if there's a radical left over, it's a non-repeating, non-terminating decimal number that comes out of it. So it wouldn't be a Pythagorean triple. Now, if we look at problem number 1 here, we have side lengths 3, 4, and x. Now, let's get here. Because x is opposite the right angle, that makes it the hypotenuse. Which for us here means it is the value of c. And because it is a right triangle, I can use the Pythagorean theorem on this triangle here to solve for x. So to do that, we're going to plug in 3 squared plus 4 squared. Or really, we're plugging in 3 and 4 for a and b, because a and b are just the side lengths here, and c is always the hypotenuse, so 3 can go in for a, 4 can go in for b, is equal to, well, we can just call c x, so we have x squared. So we get this here. Now at this point here, well, all the variables are on one side, because we're just trying to find the value of x. Now, when I look at this here, well, I have 3 squared plus 4 squared. All of this here is just a number. These are all numbers. We don't have any variables on it, so I can simplify this here. I can do 3 squared, which is 9, plus 4 squared is 16, equals x squared. Now we can combine these two because they are like terms, and 9 plus 16 is 25, which is still equal to x squared. Now we're almost done. We do need to reduce x to x, or x squared to x, because we don't really want to know the value of x squared, we want to know the value of x. So we square root both sides, because the square root and square will cancel, leaving us with x by itself is equal to, so here we need to take the square root of 25. Now, for us, the square root of 25 is 5. So our hypotenuse for problem number 1 would be 5. So when we look back at this here, so we have side lengths of 3, 4, and, well, 5. So, is this a Pythagorean triple? Well, yes. This would be a Pythagorean triple because all 3 side lengths are whole numbers. We don't have decimals, anything left over. So this would be a Pythagorean triple. And that's all we have to do for this here. Now really, if we wanted to, we could have typed 3 squared plus 4 squared in the calculator as a whole, and it would have given us 25. We could have taken the square root and gotten 5. So we could have done that because 3 and 4 are both on the same side, and they're both they're both numbers. There's no variables there, so we can just type it in. Because we could do the same thing over here on problem number 2. Because x is the hypotenuse, so it would be c. So I could say x squared is equal to, our 2 side lengths are 13 and 10. So they go for a and b. 13 squared plus 10 squared. And I know I flipped this around, but that's fine, because it's still the two legs. The sum of the square of the two legs, a squared plus b squared, is equal to the hypotenuse squared, c squared. A squared plus b squared equals c squared. I just flipped it around. Now at this point here, so we have x squared. Now just like I said on the last one, I have 13 squared plus 10 squared. Well, they're both numbers. So the nice thing is that we can type all that into the calculator and it would give us the answer. Because if I type 13 squared plus 10 squared into the calculator will tell me that it's 269. And it works out. This works out nicely because 13 squared is 169, 10 squared is 100, and 100 plus 169 is 269. Now at this point here, we can square root both sides. Take the square root of both sides, because the square root and square would cancel, giving us x by itself, is equal to. So now we need to try to take the square root of 269. Now when we do this here, the yellow calculators, the TI-30XS, the ones that y'all have, the yellow calculators, you can just type in the square root of 269 and it will give you your answer. And it works out that, well, the square root of 269 is the square root of 269. And what that tells us is that there's no perfect square factors. There's no way to simplify this lower than that without turning it into a decimal. So our answer for the hypotenuse is the square root of 269. And now we need to see, is this Pythagorean triple? Well, no. This would not be a Pythagorean triple because we don't have three whole number side lengths. So this would be no. This is not a Pythagorean triple. Now we've looked at 2 where we're trying to find the hypotenuse. Now we're going to look at 1 or 2 where we're not finding the hypotenuse. So if we look at number 3, well, number 3, right angle, 25 is opposite it, so 25 would be the hypotenuse. So that means A and B are going to be x and 24. So when we set this up here, we'd have x squared plus 24 squared is equal to 25 squared. And we have this here. Now if I notice when I'm looking at this here, well, this time, let's get a highlighter. X squared plus 24. Because on the previous 2, we had 2 whole numbers here. We had 3 and 4, 10 and 12, 13 and 13. And we could have just plugged that all into the calculator. Well, here we don't have that. I can't just plug x squared plus 24 into the calculator. It wouldn't give me the correct answer. So what we can do first is we can simplify some things. So I can do 24 squared. And you can just pull up a calculator, your TI-30XS, and type in 24 squared. And if you type that in, it'll tell you that it's 576 is equal to. Well, we're going to do 25 squared. And if I type in 25 squared in the calculator, I get 625. So we get these here. Now again, we're still trying to find out what the value of x is. So I have to get it by itself first. And to do that, we're going to subtract 576 from both sides. And when we subtract 576 from both sides, well, these here will cancel, leaving us with x squared by itself is equal to, well, now we can take 625 and minus 576 from it, which will leave us with 49. And again, just like with the previous problems, to finish this off, we're going to take the square root of both sides. And here the square root and square would cancel, leaving us with x is equal to 7. So here's our final answer, for the side lengths anyways. We see that the other side length is 7. Now what that brings us to here, or next, is, well, determining whether it's a Pythagorean triple or not. So when we look at the side lengths, we have 7, 24, and 25. Well, those are all whole numbers, so yes, it is a Pythagorean triple because we don't have any decimal places. We don't have any radicals left over. So this would be a Pythagorean triple. Okay, so we're going to look at one more of those and then we'll move on to the next type. So here, well, again, opposite the right angle is the hypotenuse, 17. So we do have the value of c, because c squared would be 17 squared. Now that leaves us with a squared and b squared. So we have 8 and x. So I can say 8 squared plus x squared equals 17 squared. So this here is still true. Now again, just like the other one, we'll have 8 squared plus x squared. So we can't just plug that into the calculator. But we can do 17 squared and 8 squared in the calculator. 17 squared is going to be 289 equals 8 squared, if we plug it in, would be 64 plus x squared. We get this here. Now again, we're trying to get x by itself, so the first thing I would do is, well, we need to get x by itself, so I would subtract 64 from both sides. The 64 minus 64 here will cancel, leaving me with x squared by itself. Now 289 minus 64 is going to be 225. And last but not least, like with the other problems, we have to square root both sides, because here the square root and square would cancel. They will cancel out, so it will give us x by itself. And now we need to see, will we be able to take the square root of 225? And yes, if we take the square root of 225, we get 15. So x would be 15. And that would be our answer. Now that leads us to our determining whether or not it's a Pythagorean triple. And because again, it's 3 whole numbers, it would be yes. Now if we get radicals left over or decimal answers, it would be no. And so that's all we need to do here to determine or find the missing side length if we're given 2. We can use the Pythagorean theorem since it is a right triangle. Now we would do the same thing here, so if you have additional questions, please get in contact with me and ask, and I will go over these. Okay, now looking at 7 through 11, we'll look at 7 and 8 specifically, but we want to determine if the following triangles are right triangles. Because if they are, then we can say yes they are. If they're not, then we'll say no. Well, how do we determine this? Well, it's going back to this here. A squared plus b squared equals c squared. Now the Pythagorean theorem only works if it is a right triangle. So if these are right triangles, then a squared plus b squared will equal c squared. And the c, the value of c, is always the hypotenuse. So if I look at number 7, well, the hypotenuse is 29. If this is a right triangle, 29 should be our hypotenuse. So what that means is 20 squared plus 21 squared is what we should have here. And I'll also try to find 29 squared. Because if this is a right triangle, the two side lengths, 20 and 21, if we square them and add it together, 20 squared plus 21 squared, should equal the value of 29 squared, because 20 and 21 will be a and b. C is 29 because the hypotenuse, c, is always the biggest side length. Now at this point here, you can plug everything into the calculator. Now 20 squared is going to be 400 plus, we can do 21 squared, which will give us 441, and if we add these two together, we would get 841. Now we need to also do 29 squared, and if we do 29 squared, we get 841. Well, hey, the values for these two here are the same, so 20 squared plus 21 squared does equal 29 squared. So a squared plus b squared equals c squared for this one here, so yes, this is a right triangle because a squared plus b squared did equal c squared, so it is true. And that's all we had to do for this one here. We just had to plug it into the Pythagorean triple. C does 20 squared plus 21 squared equal 29 squared. And if that is true, it is a right triangle. Okay. Let's do this again for number 8. Now we look at this here again, we want to figure out which one's the hypotenuse. If this is a right triangle, 62 would be the hypotenuse because it is the biggest side, which means 11 and 60 are A and B, and C would be 62. So what we do is 11 squared plus 60 squared. And see if these two will equal or be the same as 62 squared. Now 11 squared is going to be 121 plus 60 squared is going to be 3600, and 121 plus 3600 is going to be 3721. So if 62 squared is 3721, then it is a right triangle. Well, 62 squared is 3844. So these two values here are not equal. They're not the same. So that means no, it is not a right triangle. This would not be a right triangle, because a squared plus b squared has to equal c squared. So for this here, 11 squared plus 60 squared has to equal 62 squared for this to be considered a right triangle. And since it doesn't, it is not a right triangle. We would do the same things for 9, 10, and 11, as we'd figure out which side is the hypotenuse. And once we figure that out, we'll plug it into the Pythagorean theorem. And if a squared plus b squared equals c squared, then yes, it is a right triangle. But if not, we would just say, no, it is not. Okay. All right, let's look at these here. Now the next set of problems is determine if the following side lengths make an acute, right, or obtuse triangle. And so what we're going to be doing is going back to the Pythagorean theorem. What we stated already, if a squared plus b squared equals c squared, then it is a right triangle. So I put just r for right. Now, if a squared plus b squared is greater than c squared, it is acute. It's an acute triangle. That means all the angles are going to be less than 90 degrees. And if a squared plus b squared is less than c squared, or c squared is bigger than a squared plus b squared, then it is obtuse. So if a squared plus b squared is greater than c squared, it's acute. And if a squared plus b squared is less than c squared, it is obtuse. So we'll look at number 12 first. So if I look at these three lengths, well, 109 is the biggest length, so it will be c. So that means we'll have 60 squared plus 91 squared and 109 squared. And at this point here, we can plug all this into the calculator. We don't have to do this by hand like we did the last ones. Because on the last ones, if you remember, I did 60 squared and found out what it is, and then found 91 squared and found out what it is, and then added those two together. But luckily with a calculator, you can type in 60 squared plus 91 squared. And it will tell you that it's 11,881. Then we can also do 109 squared. And if we do 109 squared, we get 1, 1, 8, 8, 1. Okay, well those two are the same. So 60 squared plus 90 squared is equal to 109 squared. So that means this is a right triangle, because a squared plus b squared equaled c squared. So that means it is a right triangle. Because if the values are equal, then it will be a right triangle. Okay, now we can look at the middle one, 7, 8, 9. Well, 9 is going to be our hypotenuse because it is the biggest side. And 7 and 8 are going to be the values of a and b. So we can do 7 squared plus 8 squared and see how does it relate to the hypotenuse, 9 squared. And again, just like with the previous one, we can do 7 squared plus 8 squared into the calculator. And it'll tell us that this is 113. Then we can also do 9 squared in the calculator. And if we do 9 squared in the calculator, it'll tell us it's 81. Well, 113 is greater than 81. And since a squared plus b squared is greater than c squared, this here would be an acute triangle, because a squared plus b squared is greater than c squared. A squared plus b squared is greater than c squared means it's an acute triangle. Now we'll look at the last one here. I'm going to delete this here to make a little bit of room. Move this over here. So the last one you have is 15, 112, and 140. Well, our hypotenuse is 140, which makes 15 and 112 our legs, so A and B. So we take 15 squared plus 112 squared. And again, just like we did before, we can plug that into the calculator. 15 squared plus 112 squared. If we plug that in, we get 12,769. Now we also need to figure out what the hypotenuse is. So that would be 140 squared. And again, we can plug this in, so 140 squared would be 19,600. So when we look at this here, well, 12,769 is going to be less than 19,600. So the hypotenuse is bigger, c squared would be bigger, which means this is an obtuse triangle, because c squared was bigger than a squared plus b squared, so it would be obtuse. And that's all we have to do for these here, determining if it's right, acute, or obtuse. We're still using Pythagorean theorem, so our a squared plus b squared, and seeing how does it relate to c squared. So because if a squared plus b squared is equal to c squared, then it would be right. And if a squared plus b squared is less than c squared, then it would be acute. And if a squared plus b squared is, if a squared plus b squared is greater than c squared, this side here is bigger, then it's acute. And if c squared is bigger, c squared, our hypotenuse squared, is bigger than a squared plus b squared, then it would be obtuse. And that's all we need to do to solve these here, determine if it's acute, right, or obtuse. And we would do the same thing with 15, 16, and 17. Now that brings us to 18 through 27. Find the missing two sides for each special right triangle. Now in this here we had two types of special right triangles. We had the 45, 45, 90 and the 30, 60, 90. Now the 45, 45, 90 right triangle. So here I'll make a new page. Move this up here. Draw a triangle. It is going to be a right triangle. And two of our angles will be 45 degrees. So 45-degree angle, 45-degree angle. And the reason that these are nice is well because the sides opposite the 45 degrees are going to be the exact same. So the sides opposite 45 degrees are the same. And the side opposite the 90 degrees is going to be whatever that measurement is. Let's see here, math symbols. Well, it's going to be times the square root of 2. So it'll be easier just to write it in. So with the 45, 45, 90, the sides opposite the 45 degrees are the same. And we take whatever that measure is and multiply it by the square root of 2. So if I'm given either one of these two sides, so the sides opposite the 45 degrees, I'm going to take whatever that is, and well, that'd be the same for the other side, multiply it by the square root of 2, and I get the hypotenuse. Now if I'm given the hypotenuse, if I'm given this side here in a 45, 90, the side opposite the 90 degrees, well, if I want to get back to the two other sides, as we saw in class, we take whatever that length is and divide it by the square root of 2. So if I'm going from one of the sides opposite 45, I multiply it by the square root of 2 to get the hypotenuse, and the other side's the same because the sides opposite the 45 degrees are the same. And we take that value and multiply it by the square root of 2 to get the hypotenuse. Now if we're given the side opposite the 90 degrees, the hypotenuse, we divide it by the square root of 2 to get our two opposite sides. And that's what we do with the 45, 45, 90. Now, we'll come back and look at the 30, 60, 90 here in a minute. Let's look at some 45, 45, 90s first. Now, problem 18 is a 45, 45, 90 because I have this 45 degrees, which means this angle over here has to be 45. So these two side lengths opposite the 45 degrees will be the same. So x is going to be 7 square root of 3. So we found one of the values. Now we just need to find the value of y. Now y is going to be the hypotenuse. And the hypotenuse is whatever our side lengths are, the sides opposite the 45. We take that value and multiply it by the square root of 2. So we'll have 7 square root of 3 times square root of 2. And at this point here, we can plug this into the calculator. And if we plug it in, we'll get 7 square root of 6. So the value of y is 7 square root of 6. And these two here are our answers. And that's all we have to do for this here. Now let's look at number 19. Now again, we have another 45, 45, 90 because of the 45 degrees here. It means that this one has to be 45. So the two lengths we're finding, x and y, are going to be the same because they're opposite the 45 degrees. Now to find out what that value is, we take the hypotenuse, 6 square root of 2, and we divide it by the square root of 2. Now we can plug this in the calculator to get our answer, but square root of 2 divided by the square root of 2, anything divided by itself, simplifies to 1, which leaves us with 6. So here the value of x and y are both 6. And that's all we have to do for this here. So we're finished with that one there. So I want to look at some more 45, 45, 90s. We'll go back to the 30, 60, 90 here in a minute. So if we look at 21, This again is 45, 45, 90 because of this here. And I know x and y, which are both opposite the 45 degrees, are going to be the same. And the measure that they did give me, the side length of 4, is opposite the right angle. So this here, this 4 is the hypotenuse. And if I'm given the hypotenuse in a 45, 45, 90, to find the other two side lengths, I can take 4 and divide it by the square root of 2. Now, since there's no square root of 2 in the numerator, they won't just cancel out, they won't just cross out. But we can plug this into a calculator. The TI-30XS will simplify this for you. And if you plug 4 square root of 2 in the calculator, it will give you 2 square root of 2. So it means the values of x and y for this problem here are both 2 square root of 2 and 2 square root of 2. So that would give us our two answers for x and y. And that's all we have to do for this problem here. And any problem like it. So if I'm given the value opposite, or one of the side lengths opposite the 45 degrees, the other side length opposite the 45 degrees is the same. And to get the hypotenuse, we take whatever that length is and multiply it by the square root of 2. And if we're given the hypotenuse, well, we went through all the 45, 45, 90s. If we're given the hypotenuse like on these last two, we take whatever that measure is. It doesn't matter what the measure is. We take that length and divide it by the square root of 2. And once we divide it by the square root of 2, it will give us the two side lengths that are both opposite the 45 degrees. And that's all we have to do for these here. Now the other type of triangle that we can have, our other special right triangle, is our 30, 60, 90 degree triangle. Now we stated that the side opposite 30 degrees is x. The hypotenuse, the side opposite 90 degrees, is 2 times the shortest length, the side opposite 30. And the side opposite 60 is the shortest length times the square root of 3. So in this here, everything revolves around the shortest side. Because if I'm given the shortest side length, then I can multiply by 2 to get the hypotenuse. And I can multiply by the square root of 3 to get the side opposite 60. So in the starting setup, if they give you the side opposite 30 degrees, the shortest side length, multiply by 2 to get the side opposite 90, multiply by the square root of 3 to get the side opposite 60. Now, if they give you the side opposite 60 degrees, we're wanting to go back to the side opposite 30 degrees. Side opposite 60 degrees, if I'm given that side length, I divide it by the square root of 3, then multiply it by 2 to get the hypotenuse. Now if I'm given the side opposite 90 degrees of hypotenuse, well, I'm going to divide it by 2, then multiply it by the square root of 3 to get the side opposite 60. So it's all dependent on what side we're given. Then we're going to follow the pattern. So when we look at this one here, number 20, we have 30, 60, 90. And let's see what's given to us. 30 degrees, 5 is opposite 30 degrees. So that means we're given the side opposite 30 degrees, our shortest side length. So to get the hypotenuse, the side opposite 90, which would be y, we're going to multiply it by 2. And 5 times 2 is going to give us 10. So the hypotenuse for this triangle would be 10. And that's it. That's all we have to do for this here. Now I do need to find the side opposite 60, which would be our x. Well, we'll take the shortest side length, 5, and multiply it by the square root of 3. And 5 times the square root of 3 is, well, 5 square root of 3. And that's all we have to do for this here, and we're done. So again, all of these here are based off of the 30, 60, 90 and what we're given. So let's look at 22. Now 22 gave me the side opposite 90 degrees, our 14. So what I'm going to want to do is go back to the shortest side length. side opposite 30. Well, that would be y. Well, anytime I'm given the shortest side length to go to the hypotenuse, I would multiply it by 2. If I was given y, I'd multiply it by 2 to get 14. But to get back to the shortest side length, we take the hypotenuse and divide it by 2. And 14 divided by 2 would give us 7. So the shortest side length for this here would be 7. Because 7 times 2, if we multiply it by 2, we would get back to 14, because like on the last one and in our kind of setup, if we're given the shortest side length, the side opposite 30 degrees, we multiply it by 2 to get to the hypotenuse. And we multiply it by square root of 3 to get to the side opposite 60. So since I was given the hypotenuse, I divided by 2 to get back to the shortest side length. And now that I have it, well, if I want the side opposite 60, we take that length and multiply it by the square root of 3. And if we type that in 7 times the square root of 3, it will be just the 7 square root of 3. And that would be our answer. Okay. Let's look at number 23. Now, if we look at problem number 23, let's see what we're given. Okay, well, I'm given the side opposite 60 degrees. So if I'm given the side opposite 60 degrees, well, normally if I was given the shortest side to get to this side length, I would multiply the shortest side length, which in our case, opposite 30 degrees would be x. If I was going from x to 6, I would multiply it by the square root of 3. But since I'm trying to get back to the shortest side length, I'm not going to multiply it by the square root of 3. I'm going to take 6 and divide it by the square root of 3. Now 6 divided by the square root of 3, if we do this here and plug this here into the calculator, it will tell us that it's 2 square root of 3. So the value of x for this problem here is 2 square root of 3. That is our shortest side length. Now to go from the shortest side length to the hypotenuse is we take that 2 square root of 3 and we multiply this by 2. And 2 square root of 3 times 2 is going to be 4 square root of 3. So our hypotenuse here is 4 square root of 3. So our two answers for this here is x is 2 square root of 3 and y is 4 square root of 3. So no matter how we have this set up, if I'm given the shortest side length, we multiply it by 2 to get to the hypotenuse, and then multiply it by the square root of 3 to get to the side opposite 60. Then if we were given the hypotenuse, the longest side length, we would divide it by 2 to get to the shortest side length, and then multiply it by the square root of 3 to get to the side opposite 60. And the last case that we have is if we're given the side opposite 60 degrees, we would divide it by the square root of 3, and then multiply that, because once we divide it by the square root of 3, we would get the shortest side length. And once we find the shortest side length, we would multiply it by 2 to get to the hypotenuse. And that's all we have to do for these here. Now, if you have any other questions on these special right triangles, please ask, and I can go over them a little bit more. But that's all we have for these here, and we would do the same exact things for these. So if you have any questions, please ask. And these as well. Okay, now that brings us to our 28 and 29. Find sine, cosine, and tangent as fractions of each angle. So what they're talking about here is we're looking at sine of A, sine of angle A. Well, if we're looking at sine of angle A, sine is opposite over a hypotenuse. And for this triangle here, well, this here is the right angle, so 97 is the hypotenuse. 97 has to be the hypotenuse. So for sine of A, 97 would go on bottom. Now since sine is opposite over the hypotenuse, the opposite side is 65. So we'd have 65 over 97, and that would be sine of A. Now the next one we do have is, we have cosine. of angle A and cosine of A. Cosine is adjacent over the hypotenuse, and again the hypotenuse is still 97 because the hypotenuse is always opposite the right angle. Now again, looking back at angle A, the side adjacent to it, well, 65 is opposite because it's farthest away. So the adjacent side, the one closer to it, would be 72. So for cosine, adjacent would be 72 over 97. Now that brings us to the last one for angle A, which would be tangent of A. And tangent is opposite over adjacent. Now the opposite side, as we already said, for angle A is 65 degrees. And the adjacent side, the side next to it, would be 72. And that's all we have to do here for angle A. So sine of A would be 65 over 97. Cosine of A would be 72 over 97. And tangent of A would be 65 over 72. That's all we have to do for the setup here. Now we're not quite done. We need to find sine of the other angle. So our other angle that we have is C, this angle here. We wouldn't do anything with the right angle. We only do it with the two acute angles. Now again, sine is opposite over hypotenuse. Well, the opposite side of C would be 72, and our hypotenuse is still 97. So over here, sine of C would be 72 over 97. Now the next one we need to look at is cosine of C. And for us, cosine is always adjacent over the hypotenuse. Well, the hypotenuse would be 97. It's still the 97 because it's opposite the right angle. Now the adjacent side to C is not going to be 72 this time because that's opposite. It would be 65. And last but not least, we have tangent. And tangent of C is equal to opposite over adjacent. And this time the opposite side was 72. And the adjacent side is 65. And that's it. That's all we have to do for 28 and 29, or 28. We do this here. We have all six, sine, cosine, and tangent of A and C, the two acute angles. And the way this ends up working out is that we always have the opposite and adjacent side, and the opposite and adjacent side are always dependent on the angle. Opposite side will be the farthest away from it, adjacent side will be next to it, and the hypotenuse is always the side opposite 90 degrees. Now we would do the exact same thing for 29. Now if you have any questions, please let me know. Okay, so that brings us to 30 through 35. Now these here are not that bad. Evaluate each expression to 4 decimal places. So tangent of 49.8, if I want to find this here, we can grab the calculator, the TI-30XS, hit tangent 49.8, hit enter, and it'll tell us that this is 1.1833. So for these here, any of these here, we just have to type these into the calculator. So I can hit the sign key, 61.72. It'll tell me that 0.8806. And that's all we have to do for any of these here, is we just have to type these into the calculator and it will give us our answer. Even if we have a fraction, even if it's positive, even if it's negative, no matter what the angle is, we can type it into the calculator and it would give us our answer. Now this here, don't need that. Now these here we want to write sine as cosine or cosine as sine. So we're wanting to switch it, and what that comes down and what we're using are these here. That cosine of theta is equal to sine of 90 minus theta, and sine of theta is equal to cosine of 90 minus theta, depending on what we're given. So our first one here is sine of 67. So if I'm going to solve this, we're going to take cosine of 90 minus 67. to solve. Because according to this here, sine of 67 is equal to cosine of 90 minus 67. And if we solve that, do 90 minus 67, we get 23. So our answer is cosine of 23, because sine of 67 and cosine of 23 will have the exact same value. And we can do the same for cosine. We have cosine of 3.2. So if I want to find this value, I can take sine of 90 minus 3.2 to solve for this value here. Because this here will give us our answer. And if we type this in, and I wouldn't type in sine, we can just type in 90 minus 3.2, and if you do that, you'll get 86.7. So, make that a little bit smaller so it'll fit. Cosine of 3.2 is equal to sine of 86.7. Those will give us the exact same value. And that's all we're doing on these here. We're taking whatever angle's given, so sine of 2, so 2, subtract it from 90. 90 minus 2 would be 88. So this here would be cosine of 88. And just like with cosine, we'll take its angle, so 56, and subtract it from 90, which would give us 34. So cosine of 56, if we wanted to write it as sine, would be sine of 34. And we would do the exact same things for 40 and 41. So that's all we need to do to solve for or to rewrite sine as cosine or cosine as sine. Now these here, you just have to type these into the calculator. We can do sine inverse of sine of 81 degrees, and we'll get 81. Cosine inverse of cosine of 8.7 would be 8.7. And tangent inverse of tangent of 191 over 100 would be 191 over, on my fraction bar, 100. And that would be our answer. We can type these into the calculator, and the calculator will give us the answer for these as well. Okay. 44 through 50. So if we want to find the value of A, our angle, we've got to get it out of sine, cosine, or tangent. Now the way to undo sine, cosine, or tangent is with its inverse. So sine inverse of sine of A, these would simplify, leaving us with A by itself. And this here would be equal to sine inverse of our angle. So we'd have sine inverse of 0.7436. And to get the value of A, we would just type in sine inverse of 7.436. 7.436. And if we take sine inverse of that, we get 48.038, so or 84 or 48.04 or 48.03, either one of those is our answer. Which means on any of these here, we're just taking the inverse. So for our second one here, 46, since we're using cosine, I wouldn't use sine inverse this time. I'm going to use cosine inverse on both sides. Because cosine inverse of cosine of A will leave A by itself. And what I get over here is I have cosine inverse, because what I do to one side I have to do to the other, of 0.3496. So angle A, again, we just got to take our calculator and type in cosine inverse of 0.3496. And it'll tell us that it's 69.53 degrees. And that's it. We just have to take the inverse. of both sides. So for tangent of A, I'd take tangent inverse of both sides, which would give me A by itself is equal to tangent inverse of R 0.9874. And again, we just need to type that into the calculator. So 0.9874 for our tangent inverse. And we get 44.63 or 64 degrees. Either one will work. We just have to type this into the calculator and it will give us our answer. Now, it doesn't really matter if we have whole numbers or we don't have decimals. We have, like number 50, we have the square root of 3. It would be the exact same thing. We would take tangent inverse of the square root of 3, and it would give us our answer, or 0.5, or any of these here. We just have to take the tangent inverse of our both sides, so the tangent inverse of what it's equal to, and that will give us our decimal, or not our decimal, our angle, the angle that we're looking for. Okay. So we have two more types that we're going to look at. It's these here, 51 through 56. Solving for the missing sides using sine, cosine, or tangent. And the one we use depends on what we're given. Now, if I'm given the opposite and hypotenuse, I'm going to use sine. If I'm given adjacent and a hypotenuse, we're going to use cosine. If I'm given opposite and adjacent, we're looking for those side lengths, we're going to use tangent. Or if I'm given those setups, or those sides, then we're going to use those. So if I look at 51, well, 27 is the hypotenuse, so I'm going to use sine or cosine. Well, with the given angle 36, and the side I'm solving for x, well, that's the adjacent side and the hypotenuse, so I'm going to be using cosine, because cosine of 36 degrees is equal to the adjacent side over the hypotenuse. Adjacent side length would be x, and the hypotenuse would be 27. So we use cosine because of how it was set up. And now that we have this, we're going to solve for the value of x by multiplying both sides by 27. When I multiply both sides by 27, these will cancel. And what that'll give me is x is equal to cosine, or 27 times cosine of 36. Now again, at this point, we can plug this into the calculator. The calculator will solve this for us, because we can type in 27 cosine of 36, and 27 times cosine of 26 will tell us that x is equal to 21.84. So our side length that we're looking for, the value of x, is 21.84. And that's all we have to do for this here. That's all we need to do to solve for the missing side lengths. So we'll look at 53, and again, let's see what we have. So we're given this angle 14. Now x is opposite it, it's farthest away, so we're using either sine or tangent, because sine is opposite over the hypotenuse. Tangent is opposite over the adjacent. So let's see what else we're given. Well, we're given the side opposite 90 degrees, so that means I'm using sine of 14. Because the reason I'm using sine is because I'm given the opposite side length, which was x, and the hypotenuse. Whenever I'm given the opposite side of the angle and the hypotenuse, I use sine. Now for this here, I'm going to multiply both sides by 12. That's going to be our first main step. And when I do that, the 12 and 12 will cancel. And I have x is equal to 12 sine of 14. And I didn't say this, but like the last one, x is by itself. There's nothing being multiplied with x. We don't have x sine of 12, or we don't have the trig function or anything with x. There's nothing being added to x, nothing being subtracted, nothing being multiplied it. X is by itself, so we can plug in 12 sine of 14 into the calculator. And if we plug in 12 sine of 14, we get 2.90. So the value of x for this here is 2.9. And again, we use sine because the side we're looking for and the side we're given were the opposite and the hypotenuse of our angle. So that's what we're using to find the missing side. So we'll look at one or two more. Let's look at 54. Well, here, let's see what we're given. Well, we're given the side opposite 56 and the side adjacent. So we're using tangent. One of the other giveaways, well, since we're not looking for or trying to find the hypotenuse, the longest side length, the side that is opposite the 90 degrees, it's automatic that we're using tangent. Now tangent of 56 is going to equal the opposite side length over 14. Opposite over adjacent. Tangent is opposite over the adjacent side. Now, the first step is going to be to multiply both sides by the bottom of this fraction. So we're going to multiply both sides by 14. Because again, we're trying to get x by itself. And what I do to one side, I have to do to the other. And when I multiply both sides by 14, x is equal to 14 tangent of 56. Well, nicely enough, x is by itself. So we can type that into the calculator. 14 tangent of 56. And if we type that in, we'll see that the value of x is 20.755 or 76. Either one works. So the length of the missing side, the value of x is 20.76. And that's all we need to do for this here. So we'll look at one or two more. We'll look at two more of these here. We'll look at 55 and 56, solving for the value of x. Now when I look at 55, well, hey, we're not trying to find the hypotenuse and we're not given the hypotenuse as a length, the side opposite the 90 degrees. So that tells me that I'm going to be using tangent of 49. Tangent is going to be the trig function we use for this angle 49. Because we're not looking for the hypotenuse, we're not given the hypotenuse, so we're using tangent. Now tangent is opposite over adjacent, the opposite side length. The side farthest away from 17 is 17. Or sorry, not the farthest side away from 17. The farthest side away from 49 degrees, our angle, is 17. So it would be the opposite side length. Now the side closest to 49 degrees is x, so it would be the adjacent. So we have it set up here. Now again, we're trying to solve for the value of x. Now the first thing I'm going to do is I'm going to multiply both sides by x, because x and x will cancel. And what that gives us is x tangent of 49 degrees is equal to 17. So when we look at this here, is x by itself? Well, no, it's being multiplied by our tangent of 49 degrees. So we need this to simplify because we need x by itself. So what we can do is we can divide both sides by tangent of 49 degrees. We can't divide both sides by 49 because tangent and 49 are stuck together. Stuck together like glue. So they're not going anywhere. We can't just separate them apart. So we have to divide both sides by tangent of 49 degrees. And what that'll give us is that x is equal to 17 divided by tangent of 49. Now, x is by itself because we had to divide both sides by tangent of 49 degrees. And at this point here, now we can plug it into the calculator. We can do 17 divided by tangent of 49 degrees. And if we do that there, we get that x is equal to 14.77 or 78. And that is our answer. And that is all we have to do for this here. That's all we have to do to find the value of x. So let's look at one more of these types. We'll look at 56. So 56, they gave us the angle 68 degrees. Now we are given the hypotenuse, or not given, but we're looking for the hypotenuse. And we are given the side opposite 68 degrees. Now since we're given the side opposite 68 degrees, it means we're using sine. Because sine of 68 is equal to the opposite side length, which is 23, over the hypotenuse. Since we're looking for the hypotenuse and given the side opposite of our angle, we're going to use sine to find the value of x. Now again, just like with the last one, so we're going to multiply both sides by x. Since it's on bottom, well, we really always multiply what's on bottom first. And when we do that, we get x times sine, not sub, sine of 68 degrees is equal to 23. Well, here, just like with the last problem, x is not by itself. And since x is not by itself, we need to get it by itself. And to do that, we have to divide both sides by sine of 68 degrees. And when I divide both sides by sine of 68 degrees, well, sine of 68 degrees and sine of 68 degrees will cancel. They will cancel out. And what that leaves me with is that x is equal to 23 divided by sine of 68 degrees. So to find this value of x, to find this one we're missing now, because x is by itself, we can plug this in as 23 over sine of 68. And 23 divided by sine of 68 will give us 24.81 or 24.806. Either one of these will work, and that's our answer. That's all we have to do for this one here. Now that brings us to these last four here. We'll look at one of these here. And then we will be done. That will be everything that's going to be on these two tests. That will be Thursday and Friday. So the first thing that we're looking at is, well, we need to find all three side lengths. And we went over this at the beginning. To find the missing side length for, we'll do 57, is I use the Pythagorean theorem. That 15 squared plus 20 squared is going to equal the hypotenuse squared, x squared. And luckily for us, 15 and 20 are both on the same side, so I can type that into the calculator. Do 15 squared plus 20 squared. And 15 squared plus 20 squared is 625 is equal to x squared. Now to get x by itself, or get the hypotenuse, we have to square root both sides because the square root and square would cancel. And so at this point here, we take the square root of 625. And the square root of 625 works out to be 25. So x is equal to 25. So the value of the hypotenuse is 25. And that's the first real thing we need to do for these here. Whoops. I'll rewrite that. Is if we're looking for both angles and the missing side length, I would find the missing side length first. Because it makes finding the angles a little bit easier. Because once I find the hypotenuse, I have all three side lengths. Well, for this one here, once I find the hypotenuse, I have all three side lengths. Which means finding one of the angles is not going to be as bad. Because since I have all three side lengths, no matter what it is, so if I'm looking at angle y, so we'll find angle y first. This one up here. Well, I have opposite and hypotenuse, so I can use sine. I have adjacent and hypotenuse, so I can use cosine. And I have opposite and adjacent, so I can use tangent. So if I take sine of y, I use sine to find the missing angle. Well, sine of y is equal to opposite, 15, over the hypotenuse, which is 25. Now to get rid of sine, I take sine inverse of both sides. Because sine inverse of sine of y will cancel, leaving me with y is equal to sine inverse of 15 over 25. And at this point here, we can plug that into the calculator. We can do sine inverse of 15 over 25. And if we take that and type it into the calculator, we would get that y is equal to 36.869 or 87. So we found one of our missing side lengths is 25. We found the other missing angle, or one of the missing angles is 36.87. Now we just need to find the other angle. Well, we know that all three angles in a triangle add up to be 180. So what I can do first is I can do 90 plus 36.87. We can add those two angles together. And if we add those two angles together, we'll get 126.87. And now that we have what those two angles added together are, we can take that and subtract it from 180. And if we subtract that from 180, we will get 53.13 degrees. So that tells us angle X is 53.13. And that's how we would find the two missing angles and the missing side length. And we can do the exact same thing for 58, 59, and 60. And if you have any additional questions on any of these here or any other part of the review sheet that I didn't cover or go over, please ask so that you are ready for the test. So the first part of your test will be tomorrow, and the second part will be Friday. So hopefully this answered all your questions. If you have any others, please let me know.